दिल्ली माउड़ा रे गुलाल गुलाबी रंग केसरिया.
So this was the quadrilateral, cyclic quadrilateral. The condition is what? Condition is about the cycle and the quadrilateral. Condition is such that it is given in your book. If you take any 4 points, no specification, which is parallel, which is equal or not. Suppose you have taken, this was the center and you have taken 4 points, any 4 points. You may say 4 radius also. 4 radius, this 4 radius, 1, 2, 3 and 4. And suppose the point is A, B, C and D. So the condition is sum of the opposite angles, means angle A and angle C. Sum of the opposite angle is equal. It is given. Sum of the opposite angle is given. Angle A plus angle C. Angle A plus angle C is equal to angle B plus angle D. And obviously because all the sum of all internal angles is 360, so half is equal to 180 degree. In your book, in theorem 10.11 it is written, the sum of either pair of opposite angles, either pair means you may take A and C or B and D. Only 2 pairs of opposite things are there. So either pair of opposite angle of a cyclic quadrilateral is 180 degree. 180 degree means you may say same is also. Okay. And in class 10th you will be taught about this type of when circle is inside and quadrilateral is outside. Quadrilateral is outside. So you will be taught about sum of the opposite side is equal, means that will be AB plus CD. AB plus CD is equal to AD plus BC. AD plus BC. Sum of the opposite sides, then quadrilaterals can be formed outside of the circle. But here inside of the circle quadrilateral, that is called cyclic quadrilateral. Inside of the circle. Or just you write here, inside of circle, a quadrilateral which is inside of circle. Inscribed, this is also called inscribed circle, inscribed quadrilateral. Inscribed, okay. Cyclic or inscribed, in SCRIBED. Inscribed means inside formed. Inscribed quadrilateral. Okay. So what are the quadrilaterals which can be formed inside of this circle? So this is the general case. But where does this general case hold? So this was the general quadrilateral. So this was the condition. After that I have made so trapezium, general trapezium, you cannot make triangle in it, but isosceles trapezium you can make here. Why? How? So this is the circle, means actually trapezium is there, but the trapezium has been changed. That is why I have used this red color, red color chalk here, directly from this to this, not standing here. One pair opposite side, one pair parallel, opposite sides parallel, and as you do it parallel, the rest 2 things will be equal. How? Just check it. Parallel means I will make any 2 points first. I am free here, 2 point. This one, because I have written here second condition okay, so 2 conditions I will hold. So the first condition is there, okay, So this is any called the length, this is called this is, and when you will bisect it in class 9th it is given, when you will bisect it, it will be perpendicular, and it is called the distance of chord from the center, from the center. Okay, this is given in your theorems. This one, theorem 10.3, the perpendicular from the center of a circle to a chord bisect the chord, perpendicular. Okay, then you have the theorem equal chords of a circle, theorem 10.6, equal chord of a circle are equidistant from the center. So if you will make equal length here chord, so it will be just opposite but parallel, but it is not equal chords, but I am talking about parallel chord. So parallel chords, it may be parallel and equal also, so you will have an square. So only I am talking about parallel chord. Parallel means just extend this line, and at anywhere at you take 90 degree here, and you will draw parallel line through this parallel lines may be here, parallel lines may be here also. Parallel means this is 90 degree parallel chord. As I am not talking about the distance is same, this is the center, this is nearer, and this is the far away, and that is why you have in theorem 10.6, if the chords are equal, both may be equal from the center, otherwise it reverts, as the a small chord will be more far away from the center, and a greater chord will be nearer to the center, and at the as you increase the length, the chord greater, and at the center it will be diameter, longest chord. Okay, so this is the parallel. Other things also, you may have parallel like this also, these all are parallels. Okay, so any this is the first option, second option, third option, any side you may take, but this is the third option, this will be 1 2, third option I have told, so this will go to here and here. I have taken only general, so general points, suppose this is 1, this is only parallel, nothing about equality or not, only parallel, then these two chord will be equal means this one, isosceles trapezium. And you have a question also about this isosceles trapezium. Exercise 10.5, question number 8, about this. What? Exercise 10.5, question number 8, page number 185. The question is, if the non-parallel side of a trapezium are equal, this is, if the non-parallel sides of a trapezium are equal, then prove it is cyclic. So actually the question is start from the trapezium slipped to the isosceles trapezium. So trapezium, what is trapezium? One pair is parallel, this one, but they are only talking about the parallel, not about any equality or not equal, less than, more than. And as you join this one, so this will be unequal. These are the unparalleled things. These are the parallel, but these are unequal. So he is talking about if the unparalleled side are equal, means this, that is a cyclic quadrilateral. So in question number 8, we will start from the trapezium to the isosceles trapezium. We have to prove it, means this trapezium is not cyclic, but all the isosceles, all, one thing more, all the isosceles triangle, all the isosceles trapeziums are cyclic quadrilateral, all. Here let me write here, all. all. Actually, why the all? Because due to its construction. So question number 8 is there. Question number 8. If the non-parallel sides of a trapezium are equal, prove that it is cyclic. All isosceles trapeziums are cyclic quadrilateral. Means all, and why does it happen? Because these are the parallel and this is the equal. So to keep it equal, if these are the equal things, what does happen? A miracle happens. If you take it midpoint, and when you will join it, both will be 90 degree perpendicular because parallel. And if you will join midpoint of it, because you have a circle, you have to make a circle which will touch the vertices. Just like in triangle, if you have to make a circle which touches the vertices, you have to do perpendicular bisector of all the sides. So this will coincide, and when you will draw perpendicular bisector here, this one, this will cut on this line, and here this will also, means if perpendicular bisector of all the sides will coincide, perpendicular bisector of all the sides of a perpendicular bisector actually this is the condition, perpendicular bisector of all side coincide. All side means meet at the same place, it is called coincide. If this meet at the same place, that will be the center of the circle which will touch all the four sides. This, and this always happens in a isosceles trapezium. So this will be this will be equal. This all will be equal. Actually, if I have made only rough figure, even then it appears to be equal. This four sides are equal. It is somewhat disturbed. Four sides are equal here. Four sides are equal. So sometimes it happens, means sometimes it happens, the center of the circle may be outside of the isosceles trapezium, maybe outside, just like in triangle. If you take parallel line this, so in this case what will happen? 4 points, you have taken 4 points here, this one. So this is a isosceles trapezium, but the center of cyclic quadrilateral lies outside. So it may happen. Okay, but all isosceles trapeziums are cyclic quadrilateral. Okay. The special cases of this, will change in another one, rectangle. So this was the case. I hope you have enjoyed. Okay. Now come on, this part also. But first come on here. This was the parallelogram. After that, parallelogram to this point is rectangle. So how will you find rectangle? A rectangle is also, all rectangles are cyclic quadrilateral. One thing more, this condition also hold in this case. Why? Because this is the only trapezium, this is the isosceles trapezium. So in the isosceles trapezium, what does that happen? Because in isosceles trapezium, this side will be equal to this side, this one. Suppose I remove it, this one. So the earlier it was only trapezium, now it has changed isosceles trapezium. So in this case, why this happens always? Because in this case, this angle equal to this angle, and these angles are equal to this one. It is called isosceles trapezium because if you extend it this way, you will have an isosceles triangle. Isosceles triangle. So isosceles triangle, this is equal to this, and this is also equal to this. This was question in your class 6th, I think. No, in class 9th, but in chapter number, you have to prove it. You have to prove. Oh yes, chapter number 8, quadrilateral. So you have to prove it. And isosceles, yes. Exercise 8.1, question number 12. Again, it's again, 10.8.1, question number 12. Only 12 questions are there, and 12th number question included many theorems. So this was the target of your chapter number 8, quadrilateral target. So in this question number 12, 8.1 question number 12, it is given angle A is equal to B, angle C is equal to C. You will see it. 8.1 question number 12. Okay, because now the angles are same. Suppose it is A, B, C and D. So A and B are equal, D and C are equal. So the sum of A plus C will hold. A plus C is equal to B plus D. For this you have a theorem already taught about the parallel lines. If these are the parallel and BC is cutting here. So suppose this is the point C, this is point C and this is point B. So there is a theorem, these two angles are internal angles of the same side. So internal angles of the same sides become supplementary. Yes. So this 180 degree, this is a theorem in your chapter number, I think 6. Okay. And it has been proved B angle A. So this is angle also supplementary. So this will hold also. So when you will prove it, angle A, so B and C and A. So this was the proving of 8.1 question number 12. Okay. So you have seen all the isosceles trapezium will be cyclic in nature.